This is 6.5 of geometry. So Theorem 616 says if ABCD is a parallelogram, so if you have a parallelogram and the diagonals are perpendicular, then it is a rhombus, right? So this is just like our converse. It's almost, but... And then we've got two more that are kind of like the converse of our last section. So 617 says if it's a parallelogram, right, that's what this little bit there means. If ABCD is a parallelogram, and angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then it is a rhombus, because remember, the diagonals bisect the angles. And if ABCD is a parallelogram, 618, Theorem 618, and AC is congruent to BD, the diagonals are congruent, then we know that ABCD is a rectangle. Okay. So let's check this out here. Let's look at our first two problems here, and then we'll go to our got it problem. So can we conclude that these are a rhombus, a rectangle, or a square? And we're told that these are already parallelograms. So A says yes, right? Because these two guys are congruent, and these two guys are congruent, and I know it's a parallelogram. So yes, this is a rhombus by Theorem 617. And B, yes, the diagonals are congruent. So by Theorem 618, this parallelogram is a rectangle. So hold up a second, I want to check that out. Let's look back here at 618. So over here, I've got that those four pieces are congruent, right? Where over here, I'm only saying that the diagonals are congruent. But remember, in our parallelograms, we said that the diagonals bisect each other, right? And this is a parallelogram. So if this was just a parallelogram, I'd know that this guy is congruent to this guy, and this guy is congruent to this guy, right? But I know that these, and so this is my midpoint, right? But if I know that this guy is congruent to this guy, that means that these are all marked with just one mark. Okay, so it's going a little bit further here, but using 618, we can say that it's a rectangle. But looking back at 616, since this is perpendicular here, this means it's a rhombus. Well, if it's a rhombus and it's a rectangle, that means it's a square. So B is a square. So our got it problem, a parallelogram, let me sketch one pretty poorly. Hey, that's not bad. Has angle measures of 20... Well, let's do it this way. They're not exactly the size, but it's a little closer. 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? So I know it's a parallelogram. It can't be a rectangle or a square, right? Because rectangles and squares have right angles, and those are not 90 degrees. And it also can't be a rhombus, because I don't know if the diagonals bisect those angles. I don't know if the diagonals meet a 90-degree angle, so I can't say any. So all I know is that what they've stated, that it's a parallelogram. Okay, so I've got a picture down here of a rectangle. Well, what we want to make into a rectangle. It says, for what value of y is parallelogram DEFG a rectangle? In order for this to be a rectangle, these guys need to be congruent. So, 5y plus 3 needs to equal 7y minus 5. So I'll add 5 to both sides. I get 5y plus 8 equals 7y, and I'll subtract 5y from both sides, and I get that 8 equals 2y, divide by 2, divide by 2, y equals 4. So when y is 4, this is a rectangle, because then these guys are congruent. We can do the same thing you see up here in this problem. with a rhombus, right? We know that rhombuses bisect the angles. So if these two were congruent, then it's a rhombus. So you do the same thing where you set them equal and solve for x. And there's your homework.